Welcome, everyone. I'm Nigam Shah, one of the faculty members here and a co-director of the AIMI Center. And I'm extremely delighted to have Rachel Thomas with us, who's the co-founder of Fast.ai, where she helped create the most popular free online course on deep learning. And she's the founding director of the Center for Applied Data Ethics at the University of San Francisco, with a PhD in mathematics at Duke and an early career data scientist and software engineer at Uber. She was selected by Forbes as was one of the 20 incredible women in AI and was profiled in the book Women Tech Founders on the Rise. So Rachel, welcome and thank you for spending your time with us.
Yeah, thank you. Thanks so much for having me. I'm looking forward to the conversation.
Absolutely. So, as many of you might know, Rachel has been a strong proponent of adopting a broad lens and viewing things not just as algorithms. And one of the things that I would like to open this conversation with is, let's unpack bias a little bit. It could mean systematic difference in the output of an algorithm or a model, or it could mean a systematic difference in the benefit that accrues to a subpopulation. And the current narrative needs to talk about the interplay of three things: the algorithm, the output, the policy under which the intervention is allocated. And the biased algorithms, to me, feels like a little bit of a narrow trope. So what do you recommend we do as a community? How should we go about discussing this?
Yeah, no, I completely agree. And many people have been pointing to this issue that bias, the framing around bias often ends up too narrow and kind of really just focused on performance scores on different groups, which is certainly important, but isn't inspecting these much broader questions. And Dr. Timnit Gebru had a great article in the New York Times a few years ago where she kind of went through, like, who owns the data, who's the one applying the algorithm, and who's the population it's being applied to, and kind of all these questions about the context. And is this even something we should be doing in the first place? This particular use case, that there are a lot of broader questions we need to consider in the bias conversation. And I think something that can be maybe tricky is that some of the broader questions I think have less. They're not technical questions, and they don't have clear numeric answers in the way that evaluating performance scores on subgroups does. And so I think that can make it harder, really, for both the machine learning and medical communities to engage with these kind of more qualitative questions.
Mm-hmm. So in terms of particularly the research community, where some of us sort of live and die by writing papers and getting grants, do you have thoughts or advice for us in terms of how we adopt this broader view, this societal context, so to speak, when we frame our problems in the first place?
Yeah, and that's really, I say the incentives are kind of stacked against us. I know that many journals are publishing certain types of papers, and so often the work that is rewarded is of a very particular style and a particular quantitative style. I also think that many of these problems really point to the need for interdisciplinary work and kind of drawing from kind of very different disciplines and perspectives. And that's something else that I know has been tricky in academia, and that it tends to be pretty siloed, and particularly I think around publishing incentives. I know there are often issues of, if you publish in a journal that's kind of seen as, not directly in your department, is that really going to count towards your tenure or your career advancement? And so those are real considerations, but I think they do make it tougher for us as a community to address these problems, because I think the solutions are going to need to be kind of interdisciplinary.
And you've spent time in academia. What advice might you have for, say, an assistant professor who might be starting out in this field?
Oh, I mean, that's tough. Yeah, I don't. I've had such an unconventional career. I kind of feel like I shouldn't be giving career advice. I think finding that hopefully a balance isn't quite the right word, because it's like you want to do both, where you can be working on things that are meaningful and kind of approaching them in ethical ways, as well as, it is totally reasonable to be thinking about your career prospects and your career advancement. And so how you kind of can hold both of those, I know can be tricky.
Yeah. It's almost like having 2 feet in one canoe each, and then still trying to maintain the balance. All right. So I'm going to change gears just a teeny bit and sort of go from this broader lens to some specific examples to get your thoughts. I know you mentioned data sets and who owns the data as one of those, or where are they collected from as one of those issues. And I'll use a simple example of the ASCVD risk equation, which is used to estimate the 10-year risk of somebody having a major adverse cardiovascular event, something like a stroke or a heart attack. There's studies that have shown that these pooled cohort equations, which are widely used, probably US-wide, worldwide, tend to give miscalibrated or misestimated risk for women, Asians, and Black individuals. And we never hear about this in the news. If we look at the typical media outcry, it'll be about a specific algorithm applied at a specific place and, harms or has the potential to harm a small group of people or a population. So how do we sort of get out of this media-driven mindset, so to speak, and find the right problems where these kinds of broad approaches, looking at the data, the effect on the populations, are necessary?
Yeah, I mean, that's a tough problem. I mean, there's this kind of, I guess, underlying, part of human nature is that we think in stories. And so there's a reason that the media kind of, drives everything with this story-based storytelling, because that is, I think, what's effective with humans. But as you point out, like that doesn't capture the scale of harms or, kind of what some of the particularly maybe high impact areas to address are. I think there's also an issue around, as we were kind of talking about before, that there are so many risk scores used within medicine that are have nothing to do with machine learning, are kind of these formulaic approaches that in many cases do have very kind of biased results, or were only built using a pretty narrow population. And I think one challenge is that those problems, if you're a machine learning researcher, you may feel like, oh, like this actually, to address that doesn't draw on my background or skills or expertise. So there is something I think that's tough about, because I feel like a problem-based approach is, what would be best kind of for society of identifying high impact problems. But then often it is like, oh, this problem's kind of outside my area. The other thing I think we keep running into is often these problems have very, very deep roots of, okay, maybe this formula has been used for decades, as well as I think, as you kind of alluded to, that often these aren't seen as kind of sexy problems of it's not something new, it's not involving machine learning. So I think, and actually I'm kind of curious to hear your perspective on this, since you're closer to medicine than I am, on what you think it would take to address some of those kind of medical risk assessment scores that have been around have been in use for a while and are quite biased.
Sure. So to fill in our audience, we're sort of chatting about medical risk scores. It turns out there's something like 250,000 publications about medical risk scoring systems, and that's only till 2015. Give or take, even if just 1 out of 10 is a new score, we're talking 25,000 risk scores. If you go to a popular site like NDCalc, there's probably 500 or so different risk calculators. They're all specific to specialties in medicine, MELD score for liver failure and so on and the likes. And I struggle with the problem we just brought up, is that on the one hand, we can go and pick areas to work on based on the number of humans affected. Seems very rational, but at the same time, then who's going to work on the long right tail of scores that only affect rare populations or small populations?
Yeah.
And then on the other hand, you might go after the right tail, but then how do you scale? And so as a person who tries to straddle medicine and computer science, that's what I struggle with, is that I usually end up going after large size of people affected, conditioned on what is the chance that if I have something to say, that community will listen? Which is, it's a very subjective thing, right? I mean,
yeah.
And so I end up, in medicine and surgery, oncology, cardiology, like the people that I know understand how they think and so on. But as a computer scientist, like coming from the outside, I agree, it's quite difficult. That how do you pick where are you going to devote your finite time on this? And I would sort of challenge our audience and including our AIMI Center that we need a way to prioritize. Healthcare typically prioritizes based on lives affected and cost. And, when you have two things, multiply and then rank. I mean, that's my usual simple-minded way of ranking things. So that's where I would start probably. That is it affecting a large number of people? And is a large number of resources, either time or dollars or whatever at stake? And then we multiply by those two things and rank, recognizing it's not perfect, right? Because there's a valid reason to work on the niche problems because the solutions from there might inform the majority. So not a great answer, but that's at least how I'm thinking.
Okay, yeah, thank you. I do feel like I want to also say one note on why I still think the kind of new machine learning application that's biased, why that does have significance, even if it's hitting a small population for now. And I guess that's maybe threefold. And one of that is just, I think, when you're kind of first implementing a new technology, I do think there's, kind of a window where it will be easier to address problems. And then once something really gets adopted on a wide scale, it becomes much harder over time. So I think addressing problems now is easier than 10 years from now. And this is actually probably partly the problem with some of these risk assessments that have been in use for much longer. Is I do think the longer something's used, it can get harder to address it. And so that's kind of one reason I think that this that we should be concerned about machine learning applications now, even if the bias is affecting a relatively small number of people. The second is recognizing that often when machine learning systems are implemented, that there's it's not that everything else in the system stays exactly the same and you've just changed the the scoring mechanism or this decision maker, but often many other pieces of the system change as well. And so Paul Henman has written about, he's a professor at UQ, has written, you're not kind of just doing the same thing by computerization doesn't mean doing the same thing by different means, but you're changing, kind of changing the means or changing the kind of all parts of the system. And so I think that can be significant too, that sometimes it's not just the bias scores, but it's like, oh, are you gonna, is this going to scale things up? Is this going to change or take out the appeals process? Is this going to, are people going to be expected to kind of cycle through more cases because they're getting this computerized guidance? And so I think those questions are significant. And then the third reason, maybe I lost it, encoding difference. I'll come back. Sorry, I thought I had three, but I do think it is still significant to kind of look at machine learning applications when they have a biased outcome, and to recognize that we are kind of in this time window where a lot of new technologies being developed, and that it will be far easier to try to get it right now than to clean up the mess 10 years from now.
Absolutely, it's much easier to work with it while it's being built than to have to fix the implementation at 6,000 hospitals.
Yes.
All right. A couple of your comments brought up a couple of other ideas. We typically talk about biased algorithms and data sets and so on. But there's also sort of this larger issue, and you alluded to that a little bit, which is, is there going to be an appeals process, in the sense that what is the amount of agency that we're granting to the algorithm, and to what extent are we automating the policy, and is there some recourse? And then related to that is, again, something which you alluded to, what is going to be the change in the fiduciary responsibility of the doctor? Now that there's an algorithm that's supposed to be watching somebody, say, decompensation risk, am I off the hook? Do I not have to care about the patient? And those are issues that are not specifically about bias, but are about the use of algorithms in the process of care delivery and using algorithms as bona fide, first citizen members of the care team, so to speak. So you want to elaborate on some of your thoughts that how would we handle these two major changes, like the fiduciary agency being granted and the change in the fiduciary agency and the amount of autonomy granted to these agents?
Yeah, those are deep questions. I think of Dana Boyd has written about how bureaucracy in general has not done a great job in human history of helping with accountability or people taking responsibility for actions. It's often kind of used as a way to pass the buck. And I mean, and sometimes that's not even people intentionally trying to shift blame, but it's just in a bureaucracy, you do have so many kind of actors. And she's written about how algorithmic decision systems often are just extending bureaucracy, and we're kind of just adding even more players to kind of complicate these systems of around accountability and responsibility. And so that's really tricky. And I think also kind of looking at the pipeline of, I know there, and this has been widely documented, so many cases where patients are not being heard by their doctors in terms of getting their symptoms taken seriously or even recorded as issues. And then I know doctors also have so many issues with the demands being put on them for their time, as well as with insurance billing. And I actually personally had a kind of serious experience where my doctor actually thought that I needed a medication and was kind of abnormal in a certain level. And he actually initially basically didn't tell me because he thought that insurance wouldn't approve it. And he was like, eventually we dug into this, and he was like, your levels are abnormal, but that's using this single cutoff that doesn't take into account weight or demographic information. I actually think for you, you're in this abnormal range, but not abnormal enough to qualify for insurance. And so I know doctors are kind of facing all these constraints that limit their decision making. And so I don't have a great way forward, other than I think it's going to be super important to just be in close conversation with patients and with healthcare workers about they're going to have the best insight of what's going to be potentially kind of constraining their ability to act responsibly and take kind of search for the best outcomes. But I think that this is going to pose a lot of tricky problems.
Mm-hmm. So if I sort of look back on the things that we have touched on just in this brief conversation, there's things about the algorithm, there's things about the data set, there's things about how these agents are included in the workflow and what decisions are they making, how do those decisions affect other members of the workflow. And all of this requires, looking at existing work patterns, looking at incentives. In the US particularly, and many other places, particularly the developed world, there's insurance and their regulations to factor in. At some point, this gets really overwhelming. I'm just one guy, I want to do some good, but now I need to look at computer science, I need to look at ethics and sociology, and of course the medicine. And then at some point we just get frozen in place out of fear because maybe Stat News is going to run a bad story on me, or New York Times is going to just call me out. So how do we get out of this? In some sense, it's great that we're paying attention to all of these things, but at the same time, one person or even a small team trying to keep all of this straight in our head and make progress is a tall order. So some mistakes are likely to happen, and how do we collectively create the societal forgiveness or the bandwidth to accept that?
That's tough as well. Yeah, as you said, I think building in pauses is important where people are pausing and reflecting on kind of what they're doing and what could go wrong. But as you said, that can turn into being frozen and feeling like you can't move forward because of these risks. I think there is an element of making a very informed best faith effort, and really making sure you have consulted with all the stakeholders. And that doesn't just mean financial stakeholders, but that means anybody that's going to be impacted. And then trying to chart forward with what you see as the best course. But yeah, as you said, it's it's a tough environment for it.
So let me change gears just a little bit. I mean, it's a tough problem. We all acknowledge that. But we have a way to begin to address it by means of education. And as medical education progresses and students go through their MD and their residency and so on, there's many professional societies, including the American Medical Association, that says education about the use of data to improve patient care should be included in doctor training. Now, you're a computer scientist. If I asked you to pick like the 3 things or the 5 things that every doctor should know, like what would be on your wish list?
Oh, wow. I mean, so one is I definitely wish that more doctors had a deeper understanding of probability. And so really, recognizing, kind of when things are averages and what that means and what it means for, patients to that not everyone's going to fall, on the highest part of the bell curve, and looking at kind of these different, variations, and kind of understanding probabilistic models. So that would be high up there. I think maybe related kind of comfort and understanding with uncertainty, and that's something that I think STEM education in general, which in my background is kind of purely this STEM in terms of my formal schooling, often is not great at instilling the kind of how do you deal with uncertainty and how do you deal with areas where they're not these black and white kind of clear answers. And I think qualitative methods can be really helpful for that. And so maybe more training around qualitative methods as well, and how to incorporate information that doesn't fit into a numeric score. And I mean, that's something I want machine learning researchers to have more training on as well. So those would kind of pop to mind as few of the top things.
All right. So I think we're probably looking at time. We're probably about 7 minutes or so left. Is there a question or a topic that you would have hoped I would have brought up, but I didn't?
Yeah. Oh no, I mean this was great. Really covered a lot. I guess maybe I'll turn it back on you. What do you think some of the kind of areas for education that would kind of lead to these really high impact positive outcomes would be?
So it's a tough question. Therefore, I got to ask you first.
Yeah.
And you're turning it back to me. So I struggle with sort of the interplay of 3 things. When we use algorithms to improve decision making, particularly, and my view is mostly guided by medicine, is I want them to be useful, reliable, and fair. I mean, not necessarily in order. It's a set. I mean, all 3 need to be accomplished. And in the literature, we talk about fairness and debiasing enough. There's enough attention being paid to reliability, sometimes under the rubric of generalizability or site-to-site portability or so on. But I don't see much attention paid to usefulness. And by usefulness, I mean from decision theory, that I'm doing what I'm doing right now. Now I'm going to plunk in an algorithm. I do have some resource constraints. There's only a certain number of hours in a day and a certain number of doctors and nurses. And now I'm going to be allocating interventions based on this new thing that's going to guide my behavior. Net, am I going to improve what I'm trying to improve? Either reduce time, improve survival or quality of care, or save money, ideally all 3. But at least 2 out of those 3. And that's something that we've been trying to put some color around, that how would we quantify this? There's some nice work from the decision theory community and from the Society for Medical Decision Making that goes back to like 1975, but it hasn't merged with the machine learning and the healthcare intersection yet. So that's where I go to read and learn, is sort of the way of my of answering your question. Like that is, I think, something to include in the education. That are these things useful? Because we ask of that of drugs all the time, right? Or devices. Like, why not from algorithms? Right? I mean, they better be useful. Like, would we want something that's fair, reliable, but useless? Probably not.
Yeah, that totally makes sense. And actually, that reminds me of maybe one more I would add to the list, which is the idea of contestability. Sorry, and this is actually this is for kind of machine learning designers and kind of thinking about how you design these systems. And this has been getting more attention in the last year, but kind of planning in advance of how do you provide avenues for people to contest the algorithmic decisions. And I think often that's not even kind of considered as something that's like a desirable outcome or what's going to happen, and I think this gets back to your kind of earlier question about, mistakes are going to happen. And so some of that I think is kind of trying to build that into the design of, how do we build things in a way that the impact of a mistake can be, recognized quickly and minimized. And part of that, I think, is giving the people impacted ways to contest a decision, and whether that's a doctor saying, actually, I really think there's something wrong with this score that I'm being given, or a patient saying, this actually diagnosis really doesn't fit with what I'm experiencing. Giving the people impacted ways to kind of contest the system, and building that in as part of the system, and not seeing that as like, oh, this is terrible, but like, no, it's good to give people a way to kind of say, no, actually, I think this is wrong.
Mm-hmm, mm-hmm. So just to wrap up the conversation, like, we covered a lot of ground, touching a lot of topics. And you've been around the field for a long time. For new members coming in, like, what would be your advice on how should we keep up with all the literature and the new developments? Like, how do you keep up?
No, I mean, I would say you have to accept that you can't keep up. And so I actually, think that, I mean, some of it is, I sometimes kind of prefer to go deep on a few things, don't just, skim 20 papers, but like, choose a few of like, oh, I'm gonna go deep on this. But I think some of it is having an acceptance of like, it's such a huge quantity of research being produced. And so, and also, with that, hold this awareness that there's, I think nobody can keep up on everything going on. And so recognizing that there is stuff you're going to miss, and just trying to kind of dive deep though on a few things that you do think interest you. So maybe to not put too much pressure on yourself.
Mm-hmm. So on that sort of a humble note, I think there's a 15-minute break coming up. And after that, we'll see you all for session 4 on new developments in medical AI. Well, thank you, Rachel.
Oh, thank you.